2.5 is about multiplying decimals, and the key idea that we're going to keep coming back to when we multiply decimals is that when you are multiplying the decimals, you do not need to line the decimals up. So that's good news if that's something that you forget. It's just a habit that's different than when we're adding and subtracting. You should line all the numbers up to the right like we usually do with a multiplication problem, and then we will count the number of places after all of the decimals in the problem, and this will be how many places will be after the decimal in the answer. And don't worry if that doesn't make sense right now, because we're going to go through a lot of examples to make sure that you know exactly what that looks like. Example 1 is multiplying decimals by whole numbers, and the first thing they want us to try to do is to find 6 times 3 and 91/100ths. And I know a lot of you were asking questions about whether we should estimate or not, and we are going to do that, again, just to make sure we're in the right ballpark. So make sure you at least know how to estimate correctly so that you could use that if you wanted to. But you should write it down in these notes. All right, so when we estimate, 6 obviously can just stay 6 because we're not rounding up to a tens place or anything like that, and this one's not too hard to work with. And then if we take 391, or excuse me, 3 and 91/100ths, then we could just kind of do regular rounding rules, and this 9 would say that the 3 should become a 4. And when we multiply, and also when we get into division eventually, sometimes we pick what we call the compatible numbers, the numbers that work well and are easy to multiply in our head or divide in our head. And in this case, 6 times 4 works pretty well anyway. So we know our answer should be somewhere around 24. And now we're going to go ahead and set up the actual problem and see if our answer comes out close to that. So when we set this one up, we have kind of talked about how when we start talking about decimals and fractions, we have to change our thinking a little bit. We used to say we put the bigger number on top, but as you can see, 3, even with 3 and 91/100ths, that's technically smaller than 6, but it does happen to be longer. So we're going to go ahead and put that longer number on top, 3 and 91/100ths, and we're going to multiply by 6. And if you think about what that key idea said, we don't have to line up any decimals, we just have to line up everything to the right. So we've got the 6 directly under the 1. And then we're just going to go ahead and multiply like we normally do. So the 6 times the 1, and then times the 9, and then times the 3. And when we multiply, we end up with 2,346, what looks like 2,346. But now we've got to figure out where to put this decimal, and a lot of kids like to have like the habit of just dropping it straight down like we do in adding and subtracting, but we don't do that with multiplying. Sometimes, like in this problem, you might luck out and it might land in the right spot, but you don't want to get in the habit of just dropping that decimal straight down. What we do is we look for how many digits are after the decimal. In this case, there are 2 digits after the decimal, and then that means there are going to have to be 2 digits after the decimal in our answer. So if we go down here and we look, that would mean the decimal would have to go before the 4 so that there could be 2 digits after that. So sometimes we just say we count spots from right to left. So this would be 1 spot where the 6 is, this would be 2 spots where the 4 is, and the decimal will land right there. So that means our final answer is 23 and 46/100ths. And again, we just kind of check to see if that's reasonable and if it's close to our estimate. And if you go back and notice that our estimate was 24, you can see 23 and 46/100ths is pretty close to that. So we're probably on the right track. They have a second problem for example 1, which is to find 3 times 16,000ths. So again, we're going to quickly estimate that and just see where our answer should be close to. And in this case, again, we can just keep that 3 as the whole number 3, and then 16,000ths is so small. If you look in this tenths place, it's way less than even 1/10. So we're going to actually round that down to 0. So anything times 0 becomes 0. So we know the answer that we get is going to be pretty small. And when we set up the actual problem, again, not really the bigger number, but the longer numbers going on top. So 16,000ths is going on top times 3, and we're lining everything up to the right. And then we're just going to go through and multiply. So 3 times 6 is 18. We're going to write the 8, carry the 1. 3 times 1 is 3, plus 1 is 4. And then you can do the 3 times 0, which is 0, and then there's another 0 there. And again, we just check to see how many digits are after the decimal. So there are 3 digits up here after the decimal, which means we need 3 digits down here before we're allowed to put a decimal, and we always work from right to left when we're making that decision. And so our final answer here would be 48 thousandths, or another way to say it is 0 and 48 thousandths. And so you can tell, again, by checking that estimate, that that is pretty close to what we estimated. So we're probably on the right track. Example 2 is going to teach us a trick to use mental math, but the first method they're going to show us is how to just do the regular multiplication, and then the second method will actually be showing you that tip for how to do it mentally instead of having to set up this whole problem. So the actual question here is, how high is a stack of 100 dimes? And over here they show us that each dime has a height of 1 35 hundredths of a millimeter. And so to do this one, of course, you've got all these zeros, so you would just kind of multiply it out. And we know what it's like to multiply these zeros by everything, so we went ahead and did that. And then this is a placeholder, of course, because we had to move in to be able to do the second zero. But since we haven't done this one in a while, I wanted to kind of remind you, when you get to this digit and you're in the hundreds place, you're moving down to your third row, and you need to remember that you actually need one placeholder 0 for each of these place values. So this placeholder value, or placeholder 0, is for the ones place, and then the next one in is for the hundred, or for, excuse me, for the tens place, and then you're going to be ready to multiply the 1 by each one of these digits. So then you just go through and multiply 1 times 5, 1 times 3, and 1 times 1, and then you add just like we normally do. And then we just check up into the original problem, and we can see that there were 2 digits after the decimal, so we need to be able to move in 2 digits this way and then have the decimal right there. So that would put it between the 5 and the first 0, and that's the same thing as 135 millimeters. And that's how high the stack of 100 dimes would be then. So the actual mental math trick that you can use for method 2 is that anytime you multiply by a power of 10, remember you're thinking 10, 100, 1,000, anything that would basically be a power of 10, you can use this same trick. So you figure out how many zeros are in that power of 10. In 10 there's 1 0, in 100 there are 2 zeros, and so on. You're going to move the decimal one place to the right for each 0. So what that looks like is our original problem that we were doing with the dimes was that it was 1 35 hundredths times 100. So there are 2 zeros in 100. So that means we're going to take this decimal and move it 2 places to the right, and then that would put us with the decimal at the end of the number right there. And you can see that that's exactly what we got on method 1 without all of the extra zeros. So this is a really great trick to keep in mind, that anytime you're multiplying by a power of 10, you can just move that decimal however many spots to the right that you, for one time each 0 that you have. So again, once for this 0, a second time for this 0. And it works for any power of 10. And just another little trick, it also works for dividing, but you would go with the decimal the opposite direction. So when we multiply, we go to the right here, and when we divide, that decimal would bump to the left if we were dividing by a power of 10. So we'll practice that trick, but it's a good one to have in your back pocket every once in a while if you want to shortcut some of that side math.